Students, now let us look at the problem example for the railroad blocking problem. In this problem, we will actually take a simple scenario and look at the blocking plans of it. Consider a railroad with 4 terminals A, B, C, and D, and 3 origin destination OD demand pairs. The demands for AB, AC, and AD are 100, 80, and 90 cars, respectively. The reclassification capacities at these terminals are: for A it is 270, for B it is 90, and C 90 as well. Consider the 4 blocking plans given in the figure. So these are the 4 plans from A to D. From plan 1 is simply from A to B, B to C, and from C to D. Whereas in plan 2, it could either be directly from A to D, which is actually taking the reclassification of B and C as well. And in plan 3, the reclassification is from A to C, and then it would be delivered to the destination D. Whereas in plan 4, we are having a reclassification from A to D after taking the capacity of C flow from B and C. Now, the first plan actually sends all cars to terminal B. The string of cars may have the OD pair mix in some order. At terminal B, OD pair, the origin destination pair, AB has reached its destination. Now, the origin destination pair AC and AD are blocked to move to terminal C. So what has actually happened for the first plan? All the cars have been sent, or all the trains have been sent to terminal B. And at terminal B, the origin destination pair AB has reached. Now AC and AD would be blocked to move to terminal C. Now at C, AC has reached the terminating point, and OD pair AD is blocked to terminal D, which is its destination. So under this blocking plan, what has actually happened? 100 cars of origin destination pair AB use 1 block. 80 cars of origin destination pair AC use 2 blocks, with an intermediate reclassification at B, and 90 cars of origin destination pair AD use 3 blocks, with intermediate reclassification at B and C. So what has actually happened? In simple terms, you have used all the terminals for reclassification in plan 1. So reclassification is being done at every terminal, but it also depends upon the capacity of those terminals. We had a capacity of 270 at A, but only 90 and 90 at B and C. So reclassification of only 90 cars could be done at terminal B and terminal C. So this plan will work if you have at most the capacity of 90 to be required for reclassification. But it doesn't use the full capacity of terminal A, which is 270. Hence, blocking plan 1 results in 260 intermediate reclassifications, because reclassification is done at every terminal, which is 80 plus 2 into 90. However, blocking plan 1 is not feasible since it requires the reclassification of 170 cars, which is 80 cars for the origin destination pair AC and 90 cars for the origin destination pair AD. At terminal B, which has a capacity of only 90 cars. So this would not be, if you require a reclassification of, let's say, 170 cars, it would not be feasible, because B terminal has only a capacity of 90 cars. Similar calculations can be performed for the other blocking plans. Blocking plan has all short blocks, since block destination is always the next terminal. Now, blocking plan 4 has all direct blocks. In other words, the block destination is the same as the OD pair destination for all OD pairs. Why? Because in plan 4, every terminal can actually be reached to the destination. So block 4, plan 4 actually has the maximum number of reclassifications. But if you calculate the reclassifications, the optimal one would be coming for plan 2. That is, it would be feasible, and after feasibility, it would give you the minimum number of classifications. And you need to verify it that blocking plan 2 would be optimal with 80 intermediate reclassifications. You need to verify it. So students, we have seen the example of railroad blocking plans. So plans, these are more like a heuristic approach rather than using the mathematical model which we have discussed before. Because in this, we have some existing plan with us and we look at the optimality of it. So good enough solution would be better here. Thank you.